Welcome back to KrossUSA channel. Today we're taking you inside three remarkable operations. From the forests of Idaho to the precision mills, witness how raw timber transforms into the lumber that builds our world. Let's see how it's done. There's something timeless about watching raw timber transform into the lumber that builds America. For generations, the lumber industry has been the backbone of our construction. And nowhere is this tradition more alive than at Idaho Forest Group's Laclede facility. This isn't just another sawmill. It's a testament to how American ingenuity has evolved the age-old craft of timber processing into a modern marvel of engineering and efficiency. Let's start our journey where it all begins, deep in the forest. The harvesting operation you're seeing here represents over a century of refined forestry practices. The feller buncher you see at work is a far cry from the two-man crosscut saws your grandfather might remember. This massive machine can grab, cut, and stack multiple trees in the time it used to take to fell a single one by hand. It's equipped with a hydraulic shear that makes precision cuts, minimizing waste and ensuring each log is harvested at the optimal point. And once the trees are down, the delimbing and bucking process begins. Modern processors strip branches and cut logs to length with computer-controlled precision. Today's machinery accomplishes the same task in minutes, but the principle remains the same. Prepare the timber for its journey to the mill. Now watch these logging trucks rolling in. Each one can carry upwards of 25 tons of raw timber, and the Laclede facility processes hundreds of these loads every week. The logistics alone are impressive. Coordinating harvest sites, truck routes, and mill capacity requires the kind of planning that would make a military strategist proud. These specialized log trucks have been a fixture on American highways since the 1920s, though they've come a long way from those early pneumatic-tired models. When those logs arrive at the Laclede facility, they enter what's known as the log yard, and this is where things get really interesting. The log yard isn't just a parking lot for timber, it's a sophisticated sorting and storage system. Here's something folks don't often realize. Logs can't just sit around indefinitely. They need to be processed within a certain time frame to prevent deterioration, checking, and insect damage. That's why the flow through this yard is so carefully orchestrated. The debarking process you're witnessing is the first major transformation. Idaho Forest Group uses a ring debarker here at Laclede, a piece of equipment that's been refined over decades. The log feeds through a circular array of hydraulic arms equipped with cutting tools that peel away the bark like you might peel a potato. Except we're talking about logs that can weigh several tons. The bark isn't wasted though. It's collected and used for landscaping materials or burned as biomass fuel to help power the mill. That's the kind of efficiency our fathers and grandfathers would have appreciated, using every bit of the resource. Now here's where it gets fascinating from a historical perspective. The scanning technology you see analyzing each log would have seemed like pure science fiction just a generation ago. These laser scanners and X-ray systems map the interior of each log before it ever touches a saw blade. They're looking for knots, internal defects, rot, and determining the optimal cutting pattern to maximize the yield of quality lumber from each log. In the old days, a head sawyer relied on decades of experience and a keen eye to make these decisions. Today's systems can process this information in seconds, but they're built on that same accumulated wisdom, just translated into algorithms and computer code. The log is now moving to the primary breakdown area. Watch as the carriage system positions this massive timber. The head rig saw you're seeing is the heart of any sawmill. At Laclede, they're running a modern band mill, essentially a continuous loop of saw blade that can be up to 50 feet in circumference. These blades are engineering marvels themselves, made from high-grade steel that's precisely tensioned and sharpened. The teeth are often tipped with stellite, a cobalt-chromium alloy developed back in 1907 that can withstand tremendous heat and wear. Here's something that connects us to the past. The fundamental principle of the sawmill hasn't changed in over 2 centuries. Whether it was a water-powered up-and-down saw in 1800 or this modern band mill, we're still making parallel cuts through a log to produce dimensional lumber. What has changed is the speed, precision, and efficiency. This head rig can process a log in the time it would have taken an old-style saw to make a single cut. And as the log passes through, the cant, that's the main body after the first cuts, remove the rounded exterior, moves to the gang saws. Now, gang saws are particularly interesting from a historical standpoint. The concept dates back to the 1820s, and while the technology has advanced dramatically, the basic idea remains: multiple blades making multiple cuts simultaneously. At Laclede, these computer-controlled gang saws are making dozens of precise cuts per minute, turning that cant into dimensional lumber. your 2x4s, 2x6s, and other standard sizes that have been the building blocks of American construction since the balloon frame revolutionized home building in the 1830s. NBUT, we're not done yet. Each piece of lumber now goes through the edger. This machine trims the rough edges off each board, ensuring straight, parallel sides. The edger operator, or more accurately these days, the edger's computer system, is making split-second decisions about how to maximize value from each piece. A skilled edger can mean the difference between profit and loss in a high-volume mill like this. NTHE trimmer is next, cutting each board to standard lengths, usually 8, 10, 12, or 16 feet. Here's a bit of trivia for you. Those standard lengths weren't just picked at random. They evolved from centuries of construction practice and became standardized in America during the rapid industrialization of the late 1800s. When you're framing a house, these standardized dimensions make everything fit together like a well-designed puzzle. Now comes the grading process, and this is where craftsmanship meets technology. At Laclede, they use a combination of optical scanning and human expertise. The scanners analyze each board for defects, grain patterns, and strength characteristics, but experienced graders still verify the results. They're looking at things like knot size and placement, wane, that's where bark or missing wood appears on the edge, checking, and grain orientation. The grades, select structural, number 1, number 2, and so on, aren't just arbitrary categories. They're based on standards developed by the American Lumber Standards Committee, ensuring that a 2x4 graded at Laclede meets the same specifications as one graded anywhere else in the country. NTHE sorting system at Laclede is a choreographed dance of conveyors, diverters, and stackers. Each piece of graded lumber is routed to its designated location based on species, grade, and dimension. The facility can handle multiple species, typically Douglas fir, various pines, and other conifers native to Idaho's forests. Each species has different characteristics and uses. Douglas fir, for instance, has been prized since the pioneering days for its strength and workability, making it ideal for structural applications. Let's talk about the drying process, because this is crucial. Green lumber, that's freshly cut wood, contains a high moisture content, sometimes over 100% relative to the weight of the wood fiber itself. If you tried to build with green lumber, you'd end up with twisted, warped, and cracked structures as the wood dried. The kiln drying process at Laclede brings that moisture content down to around 15 to 19% for most applications. These modern kilns are computer-controlled chambers where temperature, humidity, and air circulation are precisely managed over several days. It's a far cry from the air-drying yards of yesteryear, where lumber might sit stacked outdoors for months or even years. And inside those kilns, you'd see stacks of lumber with spacers called stickers between each layer, allowing air to circulate around every board. The drying schedule varies depending on species, thickness, and intended use. Rush it, and you'll get defects. Take too long, and you're tying up valuable inventory. It's a balance that requires both science and experience. After drying, some lumber goes through a planing process to achieve smooth surfaces and precise dimensions. When you buy a 2x4 at the lumberyard, it's actually smaller than 2 inches by 4 inches, typically 1.5 by 3.5 inches. That's because those dimensions refer to the rough cut size. The planing process removes material to create smooth, uniform boards. This practice dates back to the standardization of lumber dimensions in the early 20th century. NTHE final packaging and shipping operation is impressive in its own right. Lumber is bundled by size and grade, wrapped to protect it from the elements, and loaded onto trucks or rail cars for distribution across America. From forest to finished product, the entire process at a facility like Laclede might take just a few days. A remarkable achievement when you consider the complexity of the operation. What you're seeing here at Idaho Forest Group's Laclede facility represents the culmination of generations of lumber industry knowledge, combined with cutting-edge technology. But at its heart, it's still about taking the renewable resource of timber and transforming it into the materials that build homes, businesses, and infrastructure across America, the same mission that's driven this industry since our nation's founding. Now let's shift gears and visit something a little different. A family-owned mill that's keeping an American tradition alive while producing one of the most innovative wood products of the modern era. Laminated veneer lumber, or LVL. There's something special about family operations like this one. While the big industrial mills certainly have their place, these smaller facilities often combine old-school values with new-school innovation in ways that larger operations can't match. LVL is a fascinating product with a history that might surprise you. While it seems ultra-modern, the concept of laminating thin wood layers together actually dates back to the 1800s. However, LVL as we know it today was pioneered in the 1970s as engineers searched for ways to create stronger, more consistent structural lumber. The beauty of LVL is that it takes lower-grade logs, timber that might not yield much high-quality dimensional lumber, and transforms them into a product that's actually stronger and more reliable than solid sawn lumber. This family operation you're seeing specializes in shorter production runs and custom orders, the kind of work that requires flexibility and attention to detail. They're primarily working with what we call plantation timber, trees grown specifically for harvest, often faster-growing species like southern yellow pine or various softwoods. These aren't the old-growth giants your grandfather might have worked with. These are second, third, or even fourth rotation trees, typically harvested at 25 to 40 years of age, depending on species and growing conditions. NTHE process begins at their log deck, where incoming timber is sorted by diameter and quality. For LVL production, they're looking for logs in that sweet spot. Not too small, but not necessarily premium sawlog quality either. One of the genius aspects of LVL is that it makes efficient use of resources that might otherwise be underutilized. Logs with knots, slight crooks, or other characteristics that would downgrade solid lumber can still produce excellent veneer for LVL watch as logs move into the debarker. This family operation uses a Rosserhead debarker, a rotating drum with protruding cutting tips that literally beats the bark off the log. It's a proven technology that's been around since the 1950s, robust and reliable, perfect for a smaller operation that needs equipment they can maintain themselves without a team of specialists. Now comes the really interesting part, the veneer lathe. This is where logs are transformed into thin, continuous sheets of wood. The log is centered and rotated against a knife blade, essentially unrolling the wood like a paper towel. It's mesmerizing to watch, and the principle is beautifully simple, though the execution requires precision. The lathe they're using here can peel veneer anywhere from 1/10 to 1/8 of an inch thick. Here's a bit of history. Rotary veneer cutting was patented back in 1818 by Samuel Bentham in England, and while the technology has certainly advanced, the fundamental concept remains unchanged after more than 2 centuries. NTHE veneer sheets coming off that lathe are still wet and flexible. They move directly to the clipper, where they're cut to width and any defects are removed. You'll notice workers monitoring this process closely. In a family operation like this, that attention to detail is part of their competitive advantage. They know their product intimately, often in ways that larger, more automated facilities can't match. NTHE veneer then goes through a dryer, a long chamber where it passes through on a conveyor system, while hot air removes moisture. This is critical because the moisture content needs to be just right for the gluing process, typically around 6 to 8%. Too wet, and the glue won't cure properly. Too dry, and the veneer becomes brittle and difficult to handle. The dryer temperature and speed are carefully calibrated based on the species of wood and the thickness of the veneer. It's the kind of knowledge that gets refined over years of hands-on experience. And after drying, the veneer goes through a grading and sorting process. They're looking at each sheet for strength characteristics, visual quality, and any defects that made it past the clipper. For LVL, the grade requirements are actually quite forgiving compared to face veneer used in plywood or furniture. Another reason this product makes such efficient use of forest resources. Now we get to the heart of LVL production, the layup and pressing process. The veneer sheets are fed through a glue spreader that applies a precise amount of adhesive, typically a phenol formaldehyde resin that creates waterproof bonds capable of withstanding tremendous stress. Here's something interesting. The adhesives used in modern engineered wood products are incredibly advanced, creating bonds that are often stronger than the wood fibers themselves. The development of these adhesives in the mid-20th century is what made products like LVL possible. NTHE glued veneer sheets are stacked with all the grain running in the same direction. That's what distinguishes LVL from plywood, where layers are cross-laminated. This parallel grain orientation gives LVL its exceptional strength in the length direction. making it perfect for beams and headers. Watch as the stack builds up. A typical LVL beam might contain anywhere from 12 to 50 layers of veneer, depending on the final thickness required. NTHE assembled stack goes into the press, a heated plate and press that applies thousands of pounds of pressure while heating the glue to cure it. The pressure ensures tight contact between layers while squeezing out excess adhesive and any air pockets. The heat accelerates the curing process, transforming liquid glue into a solid bond in a matter of minutes. In this family operation, they're running a batch press, processing one load at a time. It's not as fast as the continuous presses in large facilities, but it gives them flexibility to produce custom sizes and specifications. And after pressing, the LVL billet, that's the full width, full thickness product straight from the press, goes through a cooling period and then moves to the rip saws. These saws cut the billet into the standard widths, 1.75 inches, 3.5 inches, and so on, that match dimensional lumber sizes. The edges are trimmed clean, creating products that look professional and integrate seamlessly with conventional lumber in construction. Quality control in a family operation like this is often more rigorous than you might expect. They're typically conducting both visual inspections and regular testing to ensure their LVL meets or exceeds industry standards. These products carry their reputation, and in a family business, reputation is everything. NTHE finished LVL is bundled, wrapped, and prepared for shipment. These beams will end up in homes and commercial buildings across the region, carrying loads and spanning distances that would require much larger solid lumber. A typical LVL beam can span 30 feet or more, something that would require old-growth timber in the solid wood world. For builders and homeowners, LVL offers consistency. Every beam has predictable strength characteristics because the manufacturing process averages out the natural variations in wood. What you're seeing here represents the best of American manufacturing, a family business that's embraced modern technology while maintaining personal attention to quality. They're taking a renewable resource, using it efficiently, and producing a product that helps build America's future, one beam at a time. Let's cross the Atlantic now to Latvia, where BSW Group operates a state-of-the-art sawmill that's setting standards for quality lumber production in Europe. Now, you might wonder why we're looking at a European operation, but the truth is, the lumber industry has always been global, and innovations travel both ways across the ocean. BSW's Latvia facility represents some of the most advanced sawmilling technology in the world, much of it applicable to operations right here in America. NBSW Group has a fascinating history, stretching back to 1848 in Scotland, making them one of the oldest continuously operating sawmill companies in the world. Their Latvia facility focuses on processing Nordic timber, primarily spruce and pine from sustainably managed forests. These species are prized in construction for their straight grain, workability, and structural properties. NTHE operation breaks down into 5 main areas, each crucial to the final product. Let's start with the log yard. This isn't just storage, it's a sophisticated inventory management system. Logs are sorted by species, diameter, and quality using a combination of manual grading and automated scanning. The yard is organized so logs flow through in optimal sequence, minimizing handling and maximizing efficiency. In winter, they can store months of inventory, ensuring continuous operation even when forest conditions limit harvesting. NTHE Development Mill is where raw logs become lumber. Their primary breakdown equipment includes some of the most advanced profiling systems available. These machines use multiple saw heads that can position independently, making complex cuts in a single pass that would require multiple operations in older mills. The systems are guided by 3D scanning technology that maps each log and calculates the optimal cutting pattern in real time. This computerized approach maximizes yield. They're getting more usable lumber from each log than would have been possible even 20 years ago. NTHE gang saws and edgers here operate with tolerances measured in fractions of a millimeter. That precision means less waste and more consistent products. They're producing lumber primarily for the construction market, framing lumber, joinery timber, and specialty products. The wood coming off these saws is destined for homes and buildings across Europe and beyond. Now, the treatment plant is particularly interesting. BSW Latvia specializes in pressure-treated lumber for outdoor applications. The treatment process involves placing lumber in large pressure vessels and forcing preservative chemicals deep into the wood fibers. This isn't just surface coating. The preservatives penetrate throughout the sapwood, protecting against rot, insects, and fungal decay. The treated lumber can last decades in ground contact, making it ideal for decking, fencing, and outdoor structures. NTHE Biomass Boiler represents one of the most impressive aspects of modern sawmill operations. Every sawmill generates enormous amounts of residual material, sawdust, bark, wood chips, and trimmings. BSW's biomass boiler converts this waste into energy, producing steam for their kilns and electricity for the mill. This isn't just environmentally responsible, it's economically smart. And finally, distribution. BSW's system tracks every piece of lumber from log to delivery. Their packaging facility bundles lumber by specification, protects it for shipping, and loads it onto trucks or containers bound for destinations across Europe. The logistics coordination required is remarkable. They're managing inventory, coordinating with customers, and ensuring that the right products reach the right destinations at the right time. Every stage connects seamlessly to the next. Waste from one process becomes input for another, and technology enables a level of precision that previous generations could only dream about. These principles, efficient resource use, integration of processes, investment in technology while respecting traditional craftsmanship. These are universal values in quality lumber production, whether you're in Latvia or Louisiana.